Alrighty, now we hit the proofs. Problem 10, 11, and 12 will all be proofs. So let's see. Given triangle ABC, okay, we have a triangle, and they tell us the vertices. Awesome. They want us to prove that this triangle is a right triangle. To prove something, you either have to show that it satisfies the definition or some theorem applying to that figure specifically. Since we're dealing with a right triangle, a right triangle by definition is a triangle with one right angle. That's one way I could prove that this is a right triangle. I show that the triangle they gave me has one right angle. Okay? Or, well, if we have a right triangle, right? Right triangle, then the size of that right triangle, right? Those sides are the same. So, if I were to calculate the length of each side and then show that when I substitute it into the Pythagorean theorem that it works, you'll have some number equal to itself, it must be a right triangle. So, looking at what they give me, these are my only two options that I see at least. Um, if I were to use this Pythagorean theorem, I'd have to calculate the distance for one side, the distance for another side, the distance for a third side, and then substitute it in. Hell no, that's way too much work. I'm going to do this one by definition. I'm going to show that the triangle they gave me, right, the triangle is has at least one right angle. And I'll show that it has a right angle by showing two of the sides are perpendicular. That the slope of this one will be perpendicular to this slope. I need to figure out, and I'm lazy, right? That's why I ruled that out. I'm lazy. I need to figure out which two sides are perpendicular. I don't want to do three slope calculations. So I'm going to quickly sketch a graph. Right? Y, X, and I'm just going to quickly sketch it out. A, 1, 2 in the X direction, 0 on the Y. That's A. B, negative 1 in the X direction. 1, 2, 3, 4. All right, that's B. And C is minus 2 in the X direction. And 1, 2, 3. Right out there. So drawing out this triangle, I see that it looks like right here. It looks like that's my right angle. So the two slopes that I'm going to calculate are going to be the slope of this segment, CA, and then I'm also going to calculate the slope of BA, and that's it. And then I'll write up my proof, which is one sentence. So slope is change in y over change in x. So I'm going to have a fraction with some differences. And I'm doing C and A. C and A. So the change in my y is minus 3 and 0. Minus 3 and 0. Then it's my x, it's minus 2, 2. Minus 2 and 2. Well, negative 3 minus 0 is just minus 3. Negative 2 is minus 4. This slope is a negative divided by negative. It's a positive 3 over 4. Now let's look at the slope of BA. Slope of BA is going to be that same change in y over change in x. B and A. So I'm going to do a fraction with some fraction. My y is 4, the y is 0, so 4 minus 0. The other x is 2. Minus 1 and 2, that's 4 over minus 3. Okay? And let's see, are these slopes negative reciprocals? Here's how you check if slopes are perpendicular, all right? You multiply the slopes together. So we're going to do the slope of CA times the slope of EA. If they're perpendicular, my answer should be -1, right? That's perpendicular. That when we multiply them together, our answer will be -1, and that's how we show things are perpendicular. So the slope for CA was 3/4, and then the slope for BA was 4/-3. Well, does this equal -1? Let's see. Multiplying fractions, numerator times numerator, that's +12. Denominator times denominator, that's -12. Does that equal -1? Yeah, 12 over its negation is -1. -1 does in fact equal -1. So when I write this, I'm going to say, recently say, triangle ABC is a right triangle. And I'm thinking about how I'm going to phrase this, because I want to do it in one sentence. So triangle ABC, basically what they say, then satisfy the definition that we found. Okay, so triangle ABC is a right triangle because it has one right angle. And then we're going to explain why. Sides, we'll say two of its sides. Of its sides have slopes that are perpendicular to one another. All right, and that's it. I guess we could add in one other thing. You could, if you really wanted to, you say they're perpendicular to one another, and we're done.